Hello guys, this is Edward from STEM. Previously I showed how I built a remote control UV-VIS spectrometer using a microcontroller. And the spectrometer consists of 9 discrete wavelengths. So I decided to upgrade the wavelength to 43 wavelengths. And after doing that, I realized that the microcontroller could not uphold the code, and it makes the device to run abnormally. So I decided I'm going to upgrade the microcontroller from Arduino Nano Uno to Arduino Nano. So here it was when I was trying to use the old, after updating the wavelength, I tried to connect the device, but it's not connecting. So I've got a new Arduino Nano 3.3 with better capacity, and I replaced the old microcontroller with this new microcontroller. This is the inside of the spectrometer, and that is the old microcontroller, and I will replace that with the smaller and more capable microcontroller in terms of memory. Okay, so here it has been fixed. I have fixed it, and this is a complete setup. Now we are going to use our spectrometer. The first thing we're going to do is to connect the interface. These are interfaces are built using Excel. We connect the interface with the spectrometer using Excel data streamer. After that, then we'll start collecting of data from the spectrometer. So you're done connecting. Now let us try and run the baseline. These are baseline. I'm trying to run the baseline first. So you open the spectrometer, you put in a cuvette or sample. Okay, so use a remote control that basically helps to scan the wavelength all at once. So that is the live spectrum. So we're finished with the baseline. Now we are going to run a spectrum of a yellow food color dye, a yellow food coloring, and to see how the spectrum of a yellow food coloring will appear or look like. So this is the spectrum of the yellow food coloring, and as you can see, the maximum absorbance the maximum absorbance is at 414 nanometer, and which is pretty much similar to what you will get from the commercially made spectrometer. The other features which I included in the interface, so depending on the kind of analysis you want to carry out, you can smoothing the spectrum, and also you can find out the absorbance at other wavelengths. Okay, from the feature here, if you want to find out the absorbance at a particular wavelength, you use this feature right now, which I'm using right now. Okay, and also on my right hand side, at the right hand side of the interface, you can see you can carry out a chemical analysis. You can see you have a calibration graph there. That is where what you use to if you want to carry out a chemical analysis after preparing your standard solution and running your samples. So you'll be able to carry out your analysis and determine the concentration of your sample. Everything is done in the same interface. Okay, so this device is capable of carrying out chemical analysis, and also it can be used in field works. However, the most important reason why I built this device is to bridge the gap between students of analytical chemistry and the concept of Beer-Lambert law. Okay, this device helps to bring the concept of Beer-Lambert law closer to the students, as we all know that most schools can't afford to have high quality or commercially made spectrometer in bulk, okay, that will enable students to interact one-on-one. So most schools have spectrometer probably for one spectrometer for like 10 students or 5 students. Okay, so but with this cheap spectrometer, schools will be able to afford one spectrometer for one student, which in turn increases the chances of students in understanding the basic concept in analytical chemistry.